I'm Anil Kumar sharing with you an excellent concept from my student Anna. Anna, thanks for posting this question, and I hope many students will benefit from it. We'll talk about intermediate value theorem in this particular video, taking up two examples, how to apply the theorem, and we'll kind of extend this video by finding the root accurate to 3 decimal places for the equation cos x equals to x by using bisection algorithm. So I hope that is clear. Now let us first talk about the intermediate value theorem itself. In short, I'll be using IVT, intermediate value theorem. So it is all about a continuous function. So let me just show you what we are talking about by sketching a graph of a polynomial function. As you know, polynomial functions are continuous functions, correct? So let's say this is a polynomial function and we take up 2 points, one at x equals to a, the other one at, let's say, x equals to b. Now at a, the value of the function is going to be what? F of a, right? The value of the function at b will be f of b. So fa and fb are the values of the function f, and they are not equal, right? So there is some gap in between the two. The theorem really states that if n is any value between f of a and f of b, then there exists a c such that at x equals to c, f of c is equal to n. You get an idea, right? So intermediate values between fa and fb will definitely have independent value c where it will match. Perfect? So that's what it means. Really speaking, you could think about a line y equals to n, for example. So if I have a line y equals to n where n is in between f of a and f of b, we are assuming that f of a is smaller than f of b, correct? In that case, there is a point c where f of c is equal to n. That is what the theorem is. So if I have y equals to n, let's say this is my horizontal line, y equals to n, and in between fa and fb, if I move it, it is going to intersect the graph definitely, right? That is what it is. So I hope that concept is clear. And it is only valid for a continuous function in a closed interval. Perfect. So let's go through the theorem itself now. The wordings are kind of like this. Suppose that f is continuous on the closed interval a and b, right? So this is the closed interval a and b. And let n be any number between fa and fb, any number in between a and b, where fa is not equal to fb, right? Then there exists a number c in ab, in between a and b, x values, such that f of c is equal to n, such that f of c is equal to that value of n. Perfect. So it's kind of straightforward. If you see the graph, the function has to be continuous. So all the values between fa and fb will map to some c which is in between a and b. That's the other way of looking into it. Now I hope this concept is clear, and let's see how it could be applied to solve questions. So for that, I've taken up 2 examples. The question here is, Show that there is root for following equations in the given interval. So we have taken two examples. Question 1, the equation is x to the power of 4 plus x minus 3 equals to 0 in the interval 1 and 2. Question 2, cos x equals to x in the interval 0 and 1. Now we also have a very important algorithm. It's also a concept, which is bisection algorithm, which we'll later apply to find the roots fairly to 3 decimal places, correct? Now let's first understand this theorem and apply it to the equation x to the power of 4 plus x minus 3 equal to 0, and we're talking about the interval between 1 and 2, right? So when we say roots of the equation, right? So when we say roots of the equation, that means we want to figure out where does it intersect the x-axis, correct? So if you kind of sketch this function, let me make a rough sketch here. In that case, you'll find this is a degree 4. So somewhere the polynomial will kind of go like this and positive. So leading coefficient means both sides are up. Now let's find what is the value of this function at 1 and what is the value of the function at 2. 1 is a for you, 2 is b for you, correct? Think like this. So what is f of 1 equal to? So we'll just write 1 here. So 1 plus 1 minus 3, which is minus 1. And now let's find what is f of 2. So these are fa and fb for you. So it is 2 to the power of 4 plus 2 minus 3. So let's calculate this. 2 to the power of 4, is 16. 16 plus 2 is 18. And 18 minus 3 is 15. Perfect. So what we get here is that f of a, so the value, so n is somewhere in between minus 1 and 15. So these are the two values for this function. So think about it like this. If that is the graph, then somewhere here and somewhere there. So these are the two values we're talking about. Now definitely between these two, the graph of the function has to cross x-axis and that becomes the root, right? Now since the value changes from negative to positive, y equals to n will cross the x-axis, resulting into the root of equation, correct? So that's clear. Now it's a question of finding it out. Now to find this out, we use the algorithm which is bisection algorithm. So we'll talk about this algorithm now and we'll take up the next example to illustrate. Right? So we'll take up this example, cos x equals to x in the interval 0 to 1 to illustrate how do we really find the root. Now computers use it very effectively because iteration of operations is done very easily by computers, right? So they take no time. So all graphing calculators work in this fashion to find the roots for equations where it's very difficult to calculate otherwise. So I hope the concept is clear. Now let's take up the solution of question 2, where I will not only show that the root exists, here we are saying root exists, correct? In this case, we'll also find the root. Perfect. Let us apply our learnings of intermediate value theorem and answer the question. The question here is, show that the roots exist in the given interval. For question number 2, cos x equals to x in the interval 0 to 1. So we'll apply this theorem, which is called intermediate value theorem, to answer this question. Let me first show you the graph of both these functions and let's try to understand the situation. So when I say cos x, I mean a curve which is kind of like this, right? This is cosine function. Right? So I'm just sketching a portion of it from 0 to 1. Equals to x, y equals to x is this line. So let me write this as y equals to x. We are working in interval 0 to 1. Let's say this is 0 for us, and somewhere here we have 1. Cos of 0 is 1, so that makes sense, right? So these are the two graphs. Since they intersect at a point, that means the equation does have a solution. So that is the solution. We don't know what this value is. We are calling this as C. Now what does intermediate value theorem says? Let me reorganize this equation. We could write this as cos x minus x equals to 0, right? So we'll define our function f of x as equal to cos x minus x. And we're working in the interval 0 to 1. So let's find the value of this function for 0 and also for 1. If I substitute 0 here, I get cos 0 minus 0. We know cos 0 is 1, so we get 1 minus 0 as positive 1. And for 1, we'll get cos of 1 minus 1 equals to. Let's calculate this value using the calculator. So we have cos of 1 minus 1 equals to. We get negative 0.4596. Now clearly, from 0 to 1 interval, the value of this function changes from positive to negative. Perfect. So since it changes from positive to negative, we do have a 0 in between. So as per the intermediate theorem, there exists a number n in between, which will have the values from minus 0.4596 to, let's say, 1, right? Now, since it changes from negative to positive, we do have root also, right? So what we can find is a value c for which n is 0, right? So every value exists between these two, including 0, and therefore root exists. Right? So therefore root exists. So that is the first part. So we have understood that definitely there is a solution to this particular equation. Now we'll extend to find the solution. We use a bisection algorithm to find the solution in such cases. Now we'll talk about this. As the name suggests, bisection means find mid value, right? And then squeeze the interval repeat the process. So basically, we could rephrase the strategy as find the value, then squeeze the interval. And which value? Bisectional value, means mid value. So when I say find the value, of which point? Midpoint. So let us see how to really apply it. So we begin with the interval 0 to 1, right? Now we know that for 0 we are getting a positive value, and for 1 we are getting a negative value. We are looking for something in between. So what we will do here is that mid value is 0.5. So we'll calculate what is the value of the function at mid value 0.5. correct? So let's calculate this. So we have now cos of 0.5 minus 0.5, right, equals to 0.3775. 0.3775. So in between 0 and 1, we found that 0 plus 1 divided by 2, we get 0.5. So for this mid value, we again calculated. We got a positive value, right? This is positive. So it will replace the positive giving interval. So now we'll work in the interval, which will be from 0.5 to 1. So we kind of squeezed our interval. So now interval is smaller. Do you see that? Since we got a positive value, we replace the original point A with the new point. Now again find mid value, that is 0.5 plus 1 divided by 2. 1.5 divided by 2 is 0.75, correct? Which is 0.75. So we'll now find the value of the function at 0.75. So basically 0.75 really means we are saying cos of 0.75 minus 0.75 is what, right? So let's calculate. So we have cos of 0.75 minus 0.75 is equal to, we get a negative value of 0.0183. Clearly, you can see we are coming closer to 0, right? This time, the value is negative. Since the value is negative, we'll replace 1 with 0.75 and work in the domain from 0.5 to 0.75. Do you see how we have squeezed in? So now 0.75 gives us the negative value, 0.5 gives the positive value. In between, we could get 0. That's the whole idea. Perfect. So now again, let's find the mid value. That is to say, we'll find average of these two, 0.5 plus 0.75 divided by 2, which is what? Okay, 0.75 plus 0.5 equals to, divided by 2 is equal to, in decimals, 0.625. So we'll find the value of the function at 0.625. So at 0.625, we'll say cos of 0.625 minus 0.625 is what? That gives us a positive value of 0.1859. So the function gives us the value 0.1859. Since this is positive, which number are we going to replace? 0.5 will be replaced this time. Perfect. So we can continue this process. So now we'll work in the new interval, which will be from 0.625 to 0.75. Since we got a positive value, we are going to replace 0.5. Perfect. Again, let's find the mid value, right? So the mid value will be 0.625 plus 0.75 divided by 2, which is, let's calculate. So we have 0.625 plus 0.75 equals to, divided by 2 is equal to, in decimals, 0.6875. Let's calculate the value of the function at 0.6875. That cos of 0.6875 minus 0.6875 is equal to, we get 0.0853. So that is very close, 0.08. Do you see that? Now it is again positive, right? it is again positive. So what we get here is a positive value. So which value should we replace? We are going to again replace the value which was giving us positive answer. So now we'll work in the interval from 0.6875 to 0.75. You get an idea. And this process is repeated. So let's find a mid value between these once again. So we have 0.6875 plus 0.75 divided by 2 is equal to, in decimals, we get the value which is midway in between as 0.71875. So now, finally, let's calculate this value also for the function which is cos of 0.71875 minus 0.71875 equals 2. So it gives us a value which is equals to 0.0338. So we are very, very close to 0. You get an idea, right? So now our interval, since this is positive once again, we are going to replace this value, right? So the value which was giving us positive will be replaced by 0.71875. And we have a value here which is 0.75. So in between, we could expect a value which is very, very close to 0, right? So we have already got a value which is 2 decimal places close to the answer. Perfect. So like this, if you follow the method, you can get very accurate result. Now this can be done very easily by the computer, right? By computing or by graphing. So let's do once again. This is the last time. 0.71875 plus 0.75 equals 2. We are going to divide it by 2 and take the decimal value, which is we'll find the value of this function 0.734375, right? So we'll calculate, that's the mid value in between the two. So we'll calculate the value of our function, which is cos, I'm writing answer this time, which is the same value, minus 0.73437 equals to. So that gives us 10 to the power of minus 3. So basically 0.0078. Perfect. So that is extremely close to 0. You get an idea. So we can say that the solution of this is x equals to 0.734. So to 3 decimal places, that becomes our solution. That gives you the value of c, which will make this equation true. All right. So this iterative method may take long when we are doing it mechanically. However, using computers or graphics, it is a very effective way of solving such questions. I hope you have understood the process and also the bisection algorithm, where we take the mid value and look at the solution after the substitution of the mid value as an independent variable. If it is positive, then we replace the positive end of the x value by that. If it is negative, then we replace the one which was giving us negative value. And following this process, we squeeze in the interval and get to a solution very closely, right? So that's kind of we approach to the solution and we can go as far as we want, right? So that is how we should be doing it. So I hope the whole process is clear. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'd be great. Thanks a lot for watching and all the best.